Okay, hello everyone. At this part, we're going to introduce WLAN network access control. And from the name, you will know that actually at this part, we are going to introduce some different types of authentication to ensure the security of the network. And first is 802.1x authentication. It is a port-based network access control protocol, and it authenticates and controls connected STAs on the ports of WLAN access devices. And in this figure, the WLAN access device we use is AP. If a STA connected to a port can be authenticated, it can access resources on the WLAN, otherwise it cannot. It means that only after past the authentication, the STAs can access the network. And compared with other authentication types, if you use IEEE 802.1x, you should install a client on your STA. And this condition cannot be met in some cases. For example, if the STA is a laptop or it's a mobile, it's convenient for us to install a software on it. Right, so we can use 802.1x, right, to authenticate these STAs. But if the STA is with a printer, most of the printers cannot install softwares, so it's not that convenient. And for the network management and security purpose, network administrator still need to control the validity of such access STAs. So it means that even 802.1x is not that suitable, so we should have some other ways to authenticate the printers or some cameras in the network. And of course, in the following course, we will introduce how to achieve that purpose. Okay, and about the 802.1x, let's see the authentication process. In this figure, firstly, you can find three different equipment. First is STA, and then AP, and then is the authentication server. So the authentication process is showing in this figure. You can see they are exchanging some messages. The first state is called initialization. As the initialization state, STA will firstly send a message which is called EAPOL start to the AP. Means, okay, now I want to start the authentication. I want to access the network. And after receiving that, we will enter the next state, which is called the authentication start state. And at this state, first the AP will feedback an EAP request. And the function of EAP request is to ask STA for the user ID or the username. And of course, after receiving that, STA will feedback with an EAP response, which contains the username of this device. And actually, in this process, authentication server is responsible for the authentication. So AP is just exchanging the message between STA and the authentication server. So of course, you can see here, AP will send a radius access request to the authentication server. And in this request, it will contain the username or user ID. And after receive that, authentication server will find because in the authentication server, it will contain the relationship between the username and the password. For example, username 1 and password 1, username 2, password 2, just like this. So after receiving the username of the STA in this figure, the authentication server will find the password which is found with this username. Okay, and it will encrypt the password. And after encryption, of the password, authentication server will send a challenge, will send a radius access challenge message to the AP. And actually, the challenge is not the result of the encryption. It's a random value which have already been used to encrypt the password, which is associated with, for example, username 1. Okay, and this random value, of course, will be sent to the STA through the EAP challenge request. And it means that AP tells STA, now I will give you a value, and you should use this value to encrypt your password. And after encryption, STA will feedback the results. So EAP challenge response to the AP. AP will send it to the authentication server. You can see radius access request has been sent to the authentication server. And after receive that, the message, this message is a result of encryption of on STA, and this value will be used with that encryption value of the authentication server, and they will compare if it's the same or not. If it's the same, means the password offered by STA is the same with that stored on the authentication server, means the user has offered a right password. So the server will think that, okay, you have succeed in the authentication. So it will feedback the accept to the AP. AP will feedback the results to the STA that, okay, EAP success. And then next is the radius accounting request. You can see here, accounting, it's not authentication anymore, it's accounting. Accounting means we are going to record the behavior of this STA in the network. And for example, how long it has been accessed the network, right? And accounting response means, okay, we will start accounting. So the next state would be accounting starts. And after starting account, if the STA want to go offline, so you can see here, EAPOL, log off, means I want to go offline. I want to log off the network. So AP will ask the server to stop. You can see accounting request stop, to stop the accounting and feedback the results. Okay, and then AP will tell the STA that, okay, EAP failure, and user can go offline right now. So this is whole process of IEEE 802.1x authentication process. And it's a little complex, but you should understand the function of the messages here, and you should master the process. Okay. After introducing the .1x authentication, next it would be MAC authentication. And normally, when we use the MAC authentication, it will work together with some other types. For example, let's see a case. Now we have enabled the MAC. For example, this is a MAC authentication, and except the MAC authentication, we have enabled the portal authentication at the same time. And if the STA, for example, if the STA is starting authenticate, so firstly, it will pass the MAC authentication. If it succeeds in the MAC authentication, of course, okay, it can access the network. While if the STA failed in the MAC authentication, so next would be the portal authentication, or we can also call it web authentication. And if it succeeds in the portal authentication, it can also access the network. Okay, this is about the application scenario of MAC authentication. And since we have just mentioned the portal authentication, so let's see how does it work. Portal authentication is also called web authentication. And from the name, we can know that the authentication is related with web. And let's see how does it work. Web authentication, also known as portal authentication, uses a browser as the authentication client. Does not require installation of a separate authentication client, as shown in the following figure. When users access the internet, they must be authenticated on the web page. and hence can use internet resources. In addition, internet service providers can develop business on the web page, such as presenting merchants advertisements. Web authentication is recommended for visitors of large and medium-sized enterprises, commercial exhibitions, and public places. This is a application scenario of the web authentication. Okay, I think when you go to some shopping malls or when you go to the railway station, the airport, these kind of public places, the web authentication is common to use. When you connect to the wireless network, you will be redirected to a web page. And at the web page, normally you need to enter your mobile number and you will got a message. In the message, you can get the password and just need to enter the password, you can access the internet. This is a typical web authentication. Okay, and then let's see the common web authentication modes. Authentication based on username and password. Administrators apply for temporary account for visitors, and the visitors use a temporary account for authentication. Or next is SM-based authentication. Visitors can be authenticated by using verification codes received by mobile phones. Okay. And obviously, the second is more convenient for the users. While in some enterprise networks, even they are using the web authentication, but they want the network to be more safer. So they will prefer the first one. They will have a system to manage all these temporary accounts. And if there are some guests or some visitors of this enterprise, they will apply for some of the accounts and deliver these accounts to their visitors. Okay, this is about the web authentication. And about the web authentication, let's see the working process. Okay, firstly, the client will get an IP address first. So the first step is DHCP between the client and the AC. Okay, and after get the IP address, the client will initiate an HTTP access request because the client needs to get the web page of authentication, right? And then AC will forward the user's HTTP access request to the server to get the web authentication page. Well, sometimes in some special scenarios, if you have access to a network, but the resource you want to visit do not need to be authenticated, maybe we can skip this step. Okay, and let's say here in this example, after receiving the HTTP access request from the AC, let's see what will happen. The portal server will push the login page to the client. If you use the iPhone, the system normally will automatically redirect to the web page. While if you use some other system, you need to manually open the browser and you can get the web page. Okay, after getting the web page, the user will enter your username and password in the web page, and of course, you should click submit or some other button to send this information to the portal server. And after receive that, portal server will send a challenge message for authentication. And after receive that, AC will send an access request to the authentication and the building server. Place authentication information in a radius packet, right? And of course, they will return some information by use access accept or access reject. Accept means succeed. Reject means fail. Right? You fill in the authentication. And then the portal server will display the authentication result, push to the portal website. Means in the website you can see succeed or failed. Okay, this is about the authentication process of web. And Here are some messages we have used, and you should know them, and you should remember them. And the last step is start the building process. They will record the user's behaviors and the time, how long you have used this network. Okay, this is a web authentication process. And among these three different types of authentication modes, let's see the difference between them. And firstly, IEEE 802.1x authentication is more suitable for some new networks and networks with centralized STA deployment, high information security requirement. Actually, the most important is the last one, high information security requirements. And it needs the client software. And the advantage of it is high security, right? It's very secure. While the disadvantage is that inflexible deployment. So the deployment of this authentication type is not that flexible. And this is also the reason why it's more suitable for some new networks. Okay, and for the Mac authentication, the application scenario is that access authentication scenarios for top STAs such as printers, fax machines, and do not need any client software. And advantages are no client needed, right? And the disadvantages are need for MAC address registration and complex management. Okay, the last one, web authentication, is suitable for the scenarios with uh, scattered user and high user mobility. Do not need any client, and the deployment is flexible, while disadvantage is that the security level is low. So when you use the public Wi-Fi in some public places, if the authentication type is web, you'd better not use this Wi-Fi to, for example, pay some money or to log in some uh, payment softwares because it's not that secure. And the next is a comparison between WLAN authentication technologies. The technologies which you can find here are open, right? Policy name open, WEP open, WEP shared key, WPA, WPA2 PSK, and WPA, WPA2 802.1x. Let's see. The first is about the link authentication. Open, if the policy is open, so it's open system authentication, and WEP open is the same open system authentication. While the third one is a shared key authentication, and next is open system authentication, and the last is open system authentication about the link layer. And next about the access authentication do not support, and the WP open in combination with web authentication or Mac authentication. And next for the WEP shared key do not support. And the next is a PSK authentication. And the last for the name obviously is .1x authentication. And then for the encryption algorithm means which algorithm we use to encrypt the data. Right? For the open policy, no encryption at all. And the next is no encryption or RC4. And WEP shared key is RC4. And the last two are TKIP or AES. Right? You can choose TKIP or AES. And the recommended application scenario of them are for the open policy, the network with low security requirements, we can use it. Or for the WEP open, the public places such as airports, stations, commercial centers, or the conference halls. And then for the WEP share key, network with low security requirements. And the next, WPA, WPA2, PSK, for some home users or small and mid-size enterprises. And the last one, large enterprises with high security requirements. is a recommended application scenario. Okay, and for these different policies or for these different technologies, here are some remarks. For the open, the wireless STAs can directly access network without authentication at all. While for the WP open, the security is low when it is used alone. Any STA can access a network. It needs to be used together with web authentication or MAC authentication. And then third one, WP share key. It is not recommended because the WP security is quite low. And then next, WPA, WPA2, PSK. The security is higher than WP share key. No third-party server is needed, and the costs are low. Okay, and the last one, the security is high. A third-party authentication server is needed, and the costs are high. Okay, so you can choose the technologies you will use in your network based on these parameters here and based on your network requirements. Okay, after introducing the WLAN network access control, let's see a question together. The question is that which authentication type is suitable for printers? A, 802.1x, B, web, C, Mac. And obviously, the answer is C, right? The Mac authentication is suitable for printers, for IP cameras, for this kind of STAs that cannot install the software and cannot open any web pages. Okay, this is about this part.